Alright, I'm going to use these formulas now, show you. I kind of showed you quickly last time. If you want to actually see how to use it to make a model, we're going to make the model and use it, and hopefully you can understand how predictions are made and how this, what the slope formula kind of thing means also. So let's go. I got all this information and homework and I put it in L1 and all of these test scores from a bunch of students, and I was like, and I got all those lists of all these homeworks averages and all their test average. So their homework average ended up being a 50. Come on guys, start doing your homework. And your standard deviation of the homework is 5. The test average was a 70, not too bad, not too great. And the average, and the standard deviation, the average distance to the mean was 8. So I got these summary statistics from the sample, and I've calculated an R of 0.75. I looked at the scatter plot. I noticed it was pretty straight. I looked at the regression. I plot the residuals, and I was like, oh, kind of boring. Good. So now it's ready. I'm ready to make a model. Okay. Now let's make the model just using the formula straight up. I'm going to talk about the model, and hopefully it'll help you understand how to do this. So I want to make a model, and here it is. It's going to look like this. My predicted y is going to be some intercept plus some slope x. So I can almost write, no I can't. I don't have a b0 or a b1. So I can try to find the intercept. Let's see, what do I need for the intercept? b0 equals y minus b1 x bar. I've got my x bar and my y bar here, but I don't have a b1. So I can't find my intercept first, because I need to find b1 first and need to find the intercept. Back to the drawing board. Let's go and see if I've got enough information to get my slope. b1 is rsy over sx. Do I have that? I've got r, 0.75, sweet. Sy is 8, nice. Sx is 5, shoo-hoo-hoo-hoo. Me likey. Now, I've got this information. I can actually calculate it. 3/4 of 8, let me see, is probably 6, right? 0.75 times 8 is 6 over 5. So I get 6 over 5. This is awesome. So my B1 is simply 6 over 5. Let me double check that. Okay, good. Now, I've got my slope. Sweet. Now, I think I can, my slope is 6 over 5. Remember what that is in units. Let's interpret that real quick. 6 over 5, rise over run, my y, change in y, remember that, over change in x? 6 is change in y, so this is, y would be test score. This is points. And my slope would be, and this would be 5 would be homework average. And you know 6 over 5 is the same thing as, 6 over 5 is the same thing as what? Here we go. 6 over 5 is 1 1/5, which is 1 2/10, which is 1.2. So my slope, let's do decimals here. Why? I don't know, 1.2, because I like it. All right, so I got a slope of 1.2. Now, what do? I've got a slope, okay, so I can put that here. 1.2x. I don't have my intercept yet. I need to get an intercept. Well, let's just use the formula. The formula says simply that the intercept is y bar minus, let's get a little room here, y bar minus b1 x bar. Sweet! Do I have y bar? Yes. My b0 is y bar 70 minus b1. Oh, I already found it over here, 1.2. X bar 50. And that's what my slope is. So I can figure that out right now. B0 is 70 minus 1.2 times 50. That's 6 over 5, 50. 300 over 5 would be 15? No. Wait, 20% to 10, 60. 70 minus 60. B0 is 10. Let me double check. 1.250. Well, 150 is 50, 20% of 50 is 10, yes, 60. So my B0 is 10. Sweet. So let's put that in. 10. All right. Got my model. All right. Got my model. I've got my y-intercept, and I've got my slope. So we did it. All we did was use the formula for slope first and the formula for intercept, put it in. But let's write it in context real quickly. When I say context, are we talking about tree diameters and height? Am I talking about the arm, the length of a string on a pendulum and how long it takes to swing back and forth? No, I'm talking about homework and tests. So let's put our X and our Y in here. So I'm going to say test hat. My predicted test average is simply 10 plus 1.2 times homework average. Sweet. There's my equation. And let's see what it does to make, we can make some predictions based on this. I can predict my test score based on my homework. So someone who gets a 75 on homework, I'll put a 75 here and I'll just type in 10 plus 1.2 times 75. It'll make a prediction for test. So that's what's nice about this little guy here. But let's look at this, what our RSY SX thing means. So let's take, we know we already have 1 point on this line, 50, 70. So we know that on this line, we have the point 50, 70, okay? Let's go up 2 standard deviations. Let's go 2 standard deviations above the mean in the X direction. So the X direction, the standard deviation is 5. I'm going to go up 2 standard deviations, 5, 5. So I'm going to go up to 10. Okay? That would be 2 standard deviations, a z-score of 2. Okay? 2 standard deviations above the mean. And I'm going to see where that brings me, what my predicted y is going to be. Now, sorry, I'm going to go 10 above, which brings me up to 60, sorry. Okay, so I think if I'm 2 standard deviations above the mean in the X direction, my predicted value should probably be 2 standard deviations above the mean in the Y direction, right? Let's see. Let's go 2 standard deviations up in the Y direction. 70 plus 8 plus 8 is 86. Let's see if that's what my model predicts. So let's take 60 and put it in here. 10 plus 1.2 times 60. Okay. 10 plus 12 times 6 is, well, 12 times 60, 72. Gives me 82. So my prediction is only, oh man, 82. Oh, it's not 2 standard deviations above in the X direction, in the Y direction, is it? But it's not supposed to be. Remember, if you go 1 standard deviation above in the X direction, you only go up R standard deviations. So I went up 2 standard deviations in the X direction, so I'm going to go up R, 0.75 and 0.75. So my prediction should only be 1.5 standard deviations above. Ooh! And 1.5 eighths is 12, right? 1.5 eighths. So it should predict here 1.5 standard deviations above, which is exactly what it does. So if you ever get to the problem where they're saying, you have some model and you're going to take an X value who has a z-score of some, let's say Zx, and you're trying to predict, here's your X bar and here's your Y bar, and you're trying to predict the z-score for the Y value. Well, the predicted z-score, z and the y is just R. The z and the y is simply R times whatever the z in the X direction is, okay? So just remember that. Your z-score of your predicted is R times your z. Your zy is always R times your zx in a model, okay? Hopefully that made a little bit of sense. Had a couple of coffees. I'm kind of bouncing off the walls now. I'm going to put a couple more videos up, and hopefully you understand this is helping you out. Good luck. Good luck. Good luck.